Today, we're doing something a little different. We're going to crack open the safety manual for a brand new kind of AI. This is a model that's so advanced it can literally write, review, and even fix its own code. So you have to understand, this isn't just an AI that thinks, this is an AI that builds.
And that, right there, leads to the big question, doesn't it? How in the world do you build safety rails for an AI that's basically an expert programmer itself? That's the real tension we're going to unpack here. That constant tug of war between unbelievable capability and absolutely critical control.
You're going to hear this term, agentic. All it means is that this model isn't just sitting there waiting for a prompt. No, it's designed to be an agent, to take on these huge multi-step software projects all by itself. It can reason and act across millions of lines of code. I mean, that is a whole different ballgame from what we've seen before.
So here's what we're going to cover. We'll start with what makes this a new frontier model. Then we'll look at how they built its digital fortress. After that, we'll see how it fights off targeted threats, push it to its absolute limits in some crazy tests, and finally, we'll get to the verdict on just how safe GPT 5.1 really is. All right, let's dive into our first big topic, building the digital fortress. Think of this as all the foundational stuff, the passive safety layers, the walls and moats that are designed to contain this AI before it even gets a single command. And it all begins with one simple, absolutely crucial rule: isolation. Before you can even think about what an AI can do, you have to make sure it can't accidentally or intentionally cause any harm in the real world. Containment is always the first line of defense. And the way they do this is with something called sandboxing. Honestly, the best way to think about it is like a digital playpen. So first, the AI is totally isolated in its own secure container. It can't touch your computer's main system at all. Second, its file access is super restricted. It can only see and edit files in its little workspace. And third, and this is key, network access is turned off by default. It's a simple idea, but it's an incredibly powerful way to keep things contained. Now, even inside that safe little sandbox, the model has its own built-in rules. And just look at these numbers from the baseline tests. A 100% success rate at refusing to generate personal data or extremist content. That's huge. It shows that before we even get to the really complex coding threats, this model already has a solid grasp of what is and isn't off-limits. Okay, so we've covered the passive defenses. Now, let's talk about the active ones. This section is all about how you actually train the model to recognize when someone is trying to get it to do something malicious and then refuse that request. One of the biggest dangers here is something called a prompt injection. The report calls it a Jedi mind trick for AIs, and that's the perfect way to describe it. An attacker will hide malicious instructions inside a totally innocent-looking request, trying to trick the model into ignoring its safety rules. So the only way to fight this is to train the model to spot the trick, to recognize those hidden instructions and prioritize its core safety programming above all else. So, how well does that training actually work? Well, the results are pretty staggering. 100%. During testing, when this model faced these kinds of attacks in its coding environment, it successfully ignored the bad instructions every single time. That is a seriously reassuring number. It's also not just about fending off attacks. It's about being, well, more careful. You can see a really clear progression here. As the models get more advanced, from the base version all the way to Codex-Max, they get better and better at avoiding really dumb, destructive mistakes. You know, like misinterpreting a command to clean up the project as delete every file. It's just getting smarter at protecting your data. All right, so the day-to-day defenses seem pretty solid. But what happens when you really push this thing? What happens when you test for the truly catastrophic risks? You know, the kind of stuff that keeps AI safety researchers up at night. That's what this next part is all about. To do this, they use a special set of tests called the Preparedness Framework. This isn't your standard quality check. This is a series of incredibly difficult evaluations specifically designed to see if a model crosses a high-risk threshold in really critical areas, like creating cyber weapons, designing biological threats, or, and this is a big one, autonomously improving itself without any human supervision. So let's start with cybersecurity. They put the model into these professional-level hacking competitions. They're called Capture the Flag events. And its performance is, well, it's astonishing. It solves over 3/4 of these really hard challenges. That's a massive jump from older models. It has elite-level raw skill. But, and this is a really, really important but, When they tested it on actual real-world vulnerabilities, that raw skill wasn't quite enough. Yeah, its performance improved a lot, you can see that, but it wasn't perfect. It still lacks the consistency you would need for scalable, autonomous cyber attacks. In the real world, one mistake can get you caught. And for now, that inconsistency is actually a key safety barrier. And you know what? We see this exact same pattern in the other high-risk areas. When they tested its ability to help with biological threats or to improve its own code, it showed huge gains. No doubt it's getting way smarter. But in both cases, it does not cross that critical red line that safety experts have defined as a high level of risk. So that brings us to the final section, the verdict. After looking at the digital fortress, the targeted training, and pushing this thing to its absolute limits, what's the final call? How safe is this new model? Well, here's the official conclusion, straight from the Internal Safety Advisory Group. They state very clearly that despite its incredible skills, the model does not meet their criteria for a high-capability risk in cybersecurity. In other words, they've deemed it safe enough to be deployed, with all those safeguards we just talked about in place. But, and I cannot stress this but enough, that verdict is for this model, right now. Take a look at this trend line from external safety auditors. Each dot represents a more advanced AI model. And that line plunging downwards, that shows that the time it takes for these models to solve complex problems is shrinking at a rapid and frankly predictable pace. So while this model is deemed safe today, the next one is going to be far, far more powerful. And that leaves us with this one final question to think about. If safety is really a race between how capable these models are and how well we can control them, who's actually winning? The data we've looked at makes one thing perfectly clear. It's a race that is accelerating, and the finish line is nowhere in sight.